Let me ask you something. You've seen fire your whole life. You've lit candles, you've watched campfires, you've probably burned your finger on a stove at least once. And yet, and this is what gets me, if I asked you right now, what is that dancing yellow thing? What is the flame? Most people would say, well, it's burning, it's combustion, it's fire. And I understand that. I used to think I understood it too. But here's what I discovered that absolutely floored me. When you watch a fire burning a log, you are not watching destruction. You're watching the sun. You are watching sunlight that was captured 100 years ago being released right in front of your eyes. But he had this incredible way of making me think. And he said something I'll never forget. He said, Dick, the wood didn't go anywhere. It went everywhere. I didn't understand what he meant at the time. But that question stayed with me. Where does the wood go? You see, this is the problem with fire. We think we understand it because it's so familiar. We've been watching fire for, what? Hundreds of thousands of years as a species. And yet, when you really push on it, when you really ask what's happening, most people are completely stuck. Here's what the conventional answer sounds like. Fire is rapid oxidation. It's a chemical reaction between fuel and oxygen that releases heat and light. And that's not wrong. That's technically correct. But it's like asking, what is love? And someone says, it's a neurochemical response involving dopamine and oxytocin. I mean, yes, but come on, you've missed the whole thing. Let me tell you where my real journey with fire began. It was actually during my time at Cornell after the war. I was teaching freshman physics, and we got to the unit on thermodynamics, heat, energy, all that. And a student raised her hand and asked, Professor Feynman, why is fire hot? And I opened my mouth to give the standard answer. Rapid oxidation, exothermic reaction, energy release. But something stopped me, because I realized I was about to give her hours words instead of understanding. I could tell her what fire does. But could I explain what fire is? Could I explain why the flame glows, why it's orange at the bottom and yellow at the top? Why wood burns but rocks don't? Why a match can start a fire but sitting in the sun all day won't ignite a log? And I stood there at that blackboard, chalk in my hand, and I thought, do I actually understand this? That's when I started to really dig. And what I found, what I eventually understood, was so beautiful, so profound, that I've been trying to explain it to people ever since. Because fire isn't just chemistry. Fire is a story. It's a story that involves the sun, and trees, and time, and the very nature of matter and energy. And when you understand that story, you will never look at a flame the same way again. Let me show you what I mean. The first thing I had to understand, and this is where most people stop too early, is what's actually in the wood. Now, you look at a piece of firewood, and what do you see? You see wood, brown stuff, solid, heavy. It seems like a thing, a singular object. But here's what I want you to imagine. Get down smaller, much smaller. Get down to the atomic level, and what you'll find is that wood is actually an incredibly intricate architecture. Wood is made primarily of cellulose, long chains of carbon, hydrogen, and oxygen atoms, all bonded together in these beautiful repeating patterns. And these atoms are held together by what we call chemical bonds. Now, here's the key insight. Pay attention, because this is where my understanding started to shift. These bonds contain energy. When atoms bond together, they're in a lower energy state than when they're apart. The bond itself is like a stretched rubber band or a compressed spring. There's energy in there, locked up, waiting. So when you look at a log, you're looking at stored energy. Trillions upon trillions of tiny energy storage units, all packed together in those carbon chains. But Feynman, you might say, where did that energy come from? How did it get into the wood? No, you're asking the right question. Let me tell you what happened to me when I first really thought about this. I was walking across campus at Cornell. It was fall, the leaves were changing color, and I was still puzzling over this fire question. And I looked up at a tree, a big oak tree, and I asked myself, where did this tree come from? I mean, really, where did the stuff of this tree come from? This thing weighs tons. All that wood, all that mass, where did it come from? And the obvious answer is the ground. The tree grew up from the ground, so the stuff must come from the dirt, right? But here's what blew my mind. That's almost completely wrong. There was an experiment done a few hundred years ago by a fellow named Jan Baptist van Helmont. He grew a willow tree in a pot of soil for 5 years. The tree gained about 160 pounds. You know how much soil was lost? About 2 ounces. The tree didn't come from the dirt. The tree came from the air. I remember standing there on that campus path, looking at this enormous oak tree, and realizing this whole thing was pulled out of thin air. Literally, the carbon in the wood came from carbon dioxide in the atmosphere. The tree is made of air and water and light. This is photosynthesis, of course. But let me tell you what photosynthesis really is, because when you understand it, everything about fire will suddenly make sense. Photosynthesis. We all learned it in school. Plants take in carbon dioxide and water, and using sunlight, they make glucose and release oxygen. Fine, but let me tell you what's really happening, because this is where it gets beautiful. Sunlight, and I want you to think about this, sunlight is energy. The sun is a massive nuclear furnace 93 million miles away, fusing hydrogen into helium, and that fusion releases energy as light. Photons, little packets of energy streaming through space at 186,000 miles per second, and those photons arrive at Earth, and some of them hit leaves, and here's what happens. The energy from those photons, the actual energy that was born in nuclear fusion in the sun's core, that energy is used to rip apart carbon dioxide and water molecules. The plant takes the carbon from the cow and the hydrogen from the water, and it assembles them into new molecules. Long chains, cellulose, lignin, wood. But here's the crucial part. Here's what I want you to really get. The energy that broke those molecules apart doesn't disappear. It gets stored. It goes into the new bonds. The chemical bonds that hold cellulose together contain the same energy that came from the sun. Do you see what I'm saying? That log in your fireplace, every bit of that log was assembled using solar energy. The bonds that hold it together are made of captured sunlight. The tree didn't just grow in the sun. The tree is made of sun. When I finally understood this, I felt like I had discovered something extraordinary. I called up a colleague, I think it was Hans Beth, and I said, Hans, when you burn wood, you're releasing sunlight that was captured by the tree. And he laughed and said, Feynman, we've known this for decades. And I said, yes, but did you feel it? Did you really see it? Because knowing something intellectually and understanding it deeply, those are two completely different things. Now, let me take you further. Let me tell you about the flame itself. When you put a match to wood, you're adding energy. The heat from the match starts to break apart those chemical bonds, the ones that were formed with solar energy all those years ago. And when those bonds break, the energy is released. But wait, if the energy is released as heat, why is there light? Why does fire glow? This puzzled me for a while. I mean, heat is one thing. Heat is the vibration of atoms. But light? That's something else entirely. Here's what's happening. When wood burns, the atoms in the wood are being jiggled and smashed and excited to incredibly high energy states. Remember, we're talking about temperatures of over 1,000 degrees. At those temperatures, atoms are moving violently, and they're bumping into each other, and some of those collisions knock electrons into higher energy levels. And here's the magic of quantum mechanics, the magic I spent my life working on. When an electron drops back down from a high energy level to a lower one, it has to release that extra energy somehow. And it does so by emitting a photon, a little packet of light. That's what the flame is. That dancing, glowing orange and yellow thing, that's trillions of atoms, all heated to incandescence, all emitting photons as their electrons jump up and fall back down. The flame is not a thing. The flame is a process. It's a region where atoms are so hot that they're glowing. It's a place where ancient sunlight is being released as new light. Do you see the poetry in this? The light that heats your hands by the campfire, that light was born in the sun, maybe 100 years ago. It traveled 93 million miles to Earth, where it was caught by a leaf, stored in a chemical bond, locked away in wood. And now, a century later, it's being released. The same energy, the same light. You're warming your hands with old sun. Now here's where my understanding completely shifted, and I want to share this with you because it changed everything for me. I started asking myself, if fire is the release of stored solar energy, what happens to the atoms? Think about it. The wood burns. The flame glows. But when the fire dies down, where did all that stuff go? Remember my father's question, where does the wood go? Here's the answer, and it's magnificent. The atoms go back where they came from. The carbon that was pulled out of the air by the tree, the carbon in the keel that the tree absorbed through its leaves, that carbon goes right back into the air as coal. The hydrogen combines with oxygen and floats away as water vapor. The tree pulled those atoms out of the atmosphere, assembled them using sunlight, held them together for years or decades or even centuries, and then fire breaks them apart and returns them to the sky. Nothing is destroyed. Nothing is created. Everything is transformed. This is conservation of mass. This is conservation of energy. But it's not just a physics principle. It's a story. It's a cycle. It's the universe sea breathing. I remember discussing this with Murray Gell. Man, once. Murray was never as impressed by this kind of thing as I was. He was more into the abstract mathematics, And he said, Feynman, you're just describing thermodynamics with more poetry. And I said, Murray, the poetry is the physics. The beauty of it is not separate from the truth of it. The fact that energy is conserved, that atoms cycle through the universe, that sunlight from 100 years ago can warm my face today, that's not just facts. That's wonder. Let me tell you something else I noticed that no one else seemed to talk about. The colors of fire. You've seen that a candle flame is blue at the bottom and yellow at the top. A gas stove burns blue. A wood fire is orange and red. Why? This goes back to quantum mechanics, to the behavior of electrons in different atoms. Different atoms, when heated, emit light at different wavelengths. The color of a flame tells you about the temperature and the chemistry of what's burning. Blue flames are hotter. They contain more energetic photons. Orange and red flames are cooler. Their photons carry less energy. When you look at a candle flame, the blue at the bottom is where the combustion is most complete, where the temperature is highest. The yellow above it is incandescent carbon particles, soot, basically glowing like tiny hot coals. Every color in the fire is information. It's the atoms telling you what's happening. If you know how to read it, a flame is like a book. And here's what really gets me. The specific colors, the exact wavelengths of light, those are determined by quantum mechanics, by the arrangement of electrons in atoms, by the fundamental laws of the universe. So when you sit by a campfire and you see that orange glow, you're seeing a direct consequence of the principles that govern all of reality. The same physics that makes stars shine, that makes neon signs glow, that makes fireworks explode in different colors, it's all there in your campfire. The laws of physics are right there, dancing in front of you. But wait, I realized something even stranger. Something that, when it fully hit me, made me sit down and just stare. Let me ask you a question. Why does wood burn but rocks don't? We've established that burning is the release of stored chemical energy, so clearly wood has stored energy and rocks don't. But why? Why doesn't a rock have stored energy? Why can't you burn a rock? Here's the answer: a rock is tower already in a low energy state. The atoms in a rock, the silicon and oxygen and aluminum and whatever else, they're bonded together in configurations that don't have much stored energy to release. They're already as relaxed as they're going to get. There's no excess energy locked up in there. But wood. Wood is special. Wood is a high energy configuration of atoms. Those carbon chains, those intricate cellulose structures, they're like wound-up springs. They're ready to snap. All they need is a little kick, a little activation energy from a match, and they'll release everything they've stored. And where did that energy come from? From the sun. From the sun. This is why fire exists. Fire exists because a life exists. Without life, without plants performing photosynthesis, storing solar energy in chemical bonds, there would be no fire on Earth, no wood to burn, no leaves, no coal, no oil, no natural gas. All of our fuels are ultimately stored sunlight. Fire is not destruction. Fire is a liberation. It's the release of captured solar energy, the unbinding of what photosynthesis is bound together. Now here's what changed everything for me. Here's the thought that, when I finally had it, made me feel like I was touching something true about the nature of reality. I want you to think about time. That log in your fireplace, let's say it's from an oak tree that was 100 years old when it was cut down. That tree was gathering sunlight for a century, pulling carbon from the air, organizing it, storing energy. And the sun that was shining on that tree 100 years ago, where did that energy come from? From nuclear fusion in the sun's core. But the photons that reach Earth, the light from the sun, those photons take only about 8 minutes to cross the 93 million miles from sun to Earth. But they've been bouncing around inside the sun for thousands of years before that. The energy in that campfire, the warmth on your face, that energy was born in nuclear fusion that happened long before you were born. Before your grandparents were born. Before your great-great-grandparents. When you sit by a fire, you're feeling energy that began its journey perhaps 100,000 years ago in the sun's core, got released as light maybe 10,000 years ago, when it finally escaped the sun's surface, was captured by a tree 100 years ago, and is now being released again. You're touching ancient cosmic events with your open palms. I remember the moment this fully hit me. I was at Caltech, it was late at night, and I was working on some diagrams, my little pictures for quantum electrodynamics. And I was tired, and I had a small fire going in my study to warm the room. And I looked up at that fire, and I thought, that's the sun. That's actually the sun, not like the sun. Not a symbol of the sun. The sun has the same energy, the same light, the same photons, well, not the same photons, but the same energy, converted and stored and reconverted. Energy doesn't just disappear. It transforms. And I realized something else that night, something about the nature of reality itself. There's no such thing as destruction. When the fire burns, when the wood disappears, nothing has been lost. Not a single atom has been destroyed. Not a single unit of energy has vanished. Everything is still there. It's just in a different form. The carbon is now floating in the atmosphere as coal. The energy is now radiating outward as heat and light. The water vapor is now drifting through the air. The tree is not gone. The tree has been transformed. And if you follow this thought all the way, if you really follow it, you realize something profound about the universe. The energy in that fire, where will it go? Some of it will warm the room. Some will escape through the chimney. Some will radiate out into the night. And eventually, all of it will dissipate into the cosmos, spreading out, evening out, becoming more and more dilute. But it won't disappear. It will never disappear. That energy will still exist in some form, somewhere, forever. The sunlight that warmed your great-grandfather by his fire, that energy is still out there. Maybe it's warming some cold dust between the stars. Maybe it's been absorbed by some distant planet. But it exists, and nothing is ever truly lost. And then it hit me. This is what fire really is. This is what I've been trying to say. Fire is a window. Fire is a window into the fundamental nature of reality. When you watch a flame, you're watching energy conservation made visible. The sun's power stored and released, atoms cycling through the universe, quantum mechanics in action, time itself, past energy becoming present light, the unity of all things. Every campfire is a physics lecture. Every candle is a demonstration of conservation laws. Every burning log is a story billions of years in the making. Let me tell you what I mean by that. The carbon in that log, the carbon atoms themselves, where did TY come from? They were forged in stars. Long before our sun existed, there were other stars, bigger stars, that lived and died and exploded. And in their cores, in the unimaginable heat and pressure, hydrogen was fused into helium, helium into carbon, carbon into heavier elements. The carbon in your firewood was made in a star that exploded billions of years ago. That carbon drifted through space, became part of the cloud that collapsed to form our solar system, got incorporated into Earth, got pulled out of the air by a tree, got stored as wood, and now you're watching it burn. In fire, you're watching stardust release ancient sunlight. I don't know how to describe what it felt like when I really understood this. It was like falling in love. It was like seeing the face of someone you love and realizing they're more beautiful than you ever knew. The universe is not cold. The universe is not meaningless. The universe is profoundly connected. Every atom in your body was forged in a star. Every breath you take is shared with trees. Every fire you warm yourself by is releasing the same energy that warms the whole solar system. You are not separate from the universe. You are the universe looking at itself. When I realized this, really felt it, not just knew it, I understood why I became a physicist. It wasn't just to solve equations or win prizes. It was to see this, to feel this, to know this. And I wanted everyone to see it too. People sometimes ask me why I love physics so much. Why I've spent my life chasing these ideas, scribbling on blackboards, arguing with colleagues about things most people have never thought about. And the answer is this. It's moments like this. It's looking at something as ordinary as fire, something humans have been staring at for hundreds of thousands of years, and suddenly seeing what's really there. Every question in physics, when you follow it far enough, leads to wonder. Every phenomenon, when you truly understand it, reveals beauty. Fire is not destruction. Fire is transformation. Fire is not consumption. Fire is liberation. Fire is not the end of the wood. Fire is the wood remembering it was once the sun dies. I hope you can see what I see now. I hope that the next time you light a candle or sit by a fire or watch a match flame flicker, you'll remember. You'll remember that you're watching ancient sunlight, that you're witnessing the conservation of energy, that the warmth on your face traveled 93 million miles and waited 100 years to reach you. I hope you'll feel the connection to the sun, to the trees, to the atoms that cycle through all things, to the stars that forged everything. This is the beauty of physics. Not the equations, though those are beautiful too. Not the predictions or the technologies or the Nobel Prizes. The beauty is this. Understanding changes what you see. Once you understand fire, you can never look at it the same way again. It becomes more, not less, magical. The truth enhances the wonder rather than destroying it. That's what I've tried to give you today. Not just facts, not just answers, but a new way of seeing. And isn't that the most wonderful thing? That we can learn, that we can grow, that a universe that seems so vast and cold is actually intimately connected to every moment of our experience. The fire in your hearth and the fire in the sun are the same fire. That's what I wanted you to know.